Physics Lab Course, the Hopper Lab. We'll start with the objectives of this lab, and then we'll review some information that will help you do the lab. Kinematics equations 1 and 3. We'll briefly mention 2, but we won't need it here. We'll talk about freefall. Then we'll tell you how to do the lab, and how to do the calculations, how to analyze them, and then have a conclusion. Analysis and application questions. These would be good to give to your students. First one, what is the velocity of the large hopper at the instant before it hits the table? Try not to ask them what's the velocity when it hits the table, because a lot of kids will just say, hey, it's 0, it's stopped. You want the velocity right before it hits the table. And prove your answer using one of the given kinematics equations. So the process is first calculate V0 using the first kinematics equation. And what's your velocity at the top here, where your time is half of t max? Well, the velocity will be 0. So V0 will equal minus a times t max over 2. You just rearrange the first kinematics equation. And we're trying to find this V0 right here. We'll now reuse the first kinematics equation, but we want to find the velocity down here, which is what we asked originally. So this time, what's the difference? The time will be t max. So in the previous slide, we solved for V0, and we'll insert it into the equation there, and we get V is equal to minus a times t max over 2 plus a t max. Well, you combine those two, and you get velocity, your final velocity right before it hits the ground, is a times t max over 2. Then note, here's V0 minus a times t max over 2. Here's your final velocity. So your final velocity is negative your initial velocity. You compare these two right here. Let's switch to a graphical analysis. When you plot a line, you only need 2 points. We know that at time equals 0, the velocity is V0. That's this point right here. We also know that the velocity is 0 at time 1/2 t max. So we go ahead and plot this point. Then we connect them up and we have a velocity time graph for the Hopper lab. Since this is a velocity time graph, when we take the slope of the line, and the slope is rise over run, right, or delta y over delta x, we have v over t, which is the acceleration. And in this case, since the hopper is in free fall once it's launched, the only acceleration is due to gravity. That's the definition of free fall. The acceleration and the slope of the graph should be negative 9.8 meters per second squared.